This is Free Range Digital Design Foundation Modeling. This is Chapter 5, second video. Previous video we covered the first two bullets, and in this video we're going to talk about some useful codes associated with digital design. So a code is just a set of bits or numbers that represent something, not a big deal. A few codes that are very important in digital design, we'll be talking about those in this chapter. And of course this chapter, once again, still preliminary work. We're not going to really be doing any digital design until the next chapter. We as humans are very good at understanding decimal, while computers understand binary. Inherently, we're always translating back and forth between what the computer wants and what we understand. And one of the primary ways to do this is with binary coded decimal. So essentially, as the name says, what we're going to be doing is developing a special code, a binary code, to represent the decimal digits. Remember, there are 10 decimal digits, 0 through 9. The issue here is we have 10 digits, but we can only represent 8 things with 3 bits, so we have to use 4 bits. With 4 bits, we can represent 16 things, which covers the 10 decimal digits, but we have essentially 6 unused locations, 6 unused codes right here for whatever 10 through 15, which is kind of what we use it for later. But these, in a strict binary coded decimal code, these 6 codes that are on the right here are not used. So most important thing to realize here is this is not a strict unsigned binary number. This is binary coded decimal, which we'll see is different. Although they look the same, they're just ones and zeros, they are not the same. Okay, so here's a couple examples here. It's very straightforward to convert back and forth between BCD and decimal. It uses a groups of 4 approach, which you've seen before. Let's do this. 247 will be 247, and what I do is need to pull up the groups of 4 or refer back to the table on the previous page. So 2 gets encoded as 0010, 4 is a 0100, and 7 is 0111. And these numbers, I need to note that this is a BCD number. I do that, of course, with a subscript here. Notice that each of these digits is represented by 4 bits. Typically speaking, even though these first 2 bits are 0 here, we write them anyway. So 32.75, it's the same approach here. 32.75. The decimal point's kind of a not part of the number, but we'll retain it anyway. So it's 0011 for the 3, 0010 for the 2. We'll drop a decimal point down there. 0111 for the 7, and 0101 for the 5. Now there's my decimal to BCD conversion, groups of 4, and I did include the subscripting BCD to officially describe what those numbers are. Next example here, we're converting from BCD to decimal, so we got to be careful here. I'm going to do a groups of 4. I'm just going to draw a line between these things and then do it directly. See if I get this right. Okay, looking good. Alright, so doing this first example, I put it into groups of 4. So the first digit over here is a 9, this is a 3, this is a 0, and this is a 1. So these are equivalent. It's decimal. I'm not going to put a 10 subscript on it. Okay, the same idea for this other example. Too bad those don't match up a little bit better. Oh, it has a decimal point in there. So this is an 8 out of 1. 8.102. Here's the 1, here's the 0, here's the 2. So lastly here, I have an example of numbers that look the same. They're both binary numbers. One's in BCD format. The other one is in just strict unsigned binary format. So I want to know which one's bigger. And so I'm going to do the conversions on this first one. This is BCD. So this is going to be 90, and this is a 5. And the conversion on this one is going to be, I'll convert this to a hexadecimal first. It's going to be 60 base 16, which is 6 times 16 equals 96. So this number is bigger because it's 96. Okay, we'll do this Same thing on this example. This is the 37. Converting these using a groups of 4. This number here is I'll convert it to hex first, which is a 37 base 16, which equals 3 times 16 plus 7 equals 55. 3 times 16, 40. Okay, looks good. So both examples here, the number on the right is larger. Oftentimes in digital design, we need to represent something with a one-hot code. So one-hot code, we don't really use it that much, but it's a great interview question. What's one-hot code? Super straightforward idea, really easy. Once you see it, you'll never forget it. It does come up a little bit in digital design. It comes up under the notion of turning one of many things on. So that's what the one-hot code here is. It means that one of the bits in the code is a 1, all the other bits are a 0. One thing to notice in this thing is all these codes have equivalent bit widths. And this code right here, this is a 3-bit one-hot code. There's 3 bits, and each of those code words, only one of the ones is set. Same with the 4-bit code. All the codes have 4 bits. Only one of those bits is a 1 at a given time. Same with the 5 and 6-bit codes here. I'm not going to talk too much about those. There are also 1 cold codes. So the 1 cold codes are simply the opposite of the 1 hot codes, which means I make a 0, a 1, and a 1 and a 0 for all the code words. And I believe we have an example of this coming up here. So for 1 cold, a 5-bit 1 cold code, that means all the code words have 5 bits, so they're going to be 5 code words. Let's write them out. It's going to be 1, 1, 1, 1, 0. There's your 1 cold code. 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1. So there's your 5-bit 1 cold code. Once again, it's the opposite of the 1 hot code. Only 1 0 is coded at any given time. Last code here is unit distance codes. So we don't really use those that much. They come up sometimes, and certainly once again in an interview. So you got to know them. It's a simple idea. It's very useful in some fields, but not in just straight digital design. Oftentimes these unit distance codes are called gray codes, which is not exactly true. Gray codes have another special property that we don't need to mention now. And one other topic on these codes is these are 2 code words sitting down here, and they're inherently circular. So this is like the first code word over here. This is the last code, the code word after the last code word. The next code word after the last code word is the first code word again, and we'll go over that in a second. So the idea here of distance is a very simple concept. We talk about the distance between 2 code words. So the distance between 2 code words is the number of bits I need to change to get to the other code word. So the idea here is distance between these is 1101. These 2 match. These 2 bits match. What do I have to do to go back and forth between these is toggle that bit right there. So that distance equals 1. For the other code word, I got 11001 and 11000. Once again, the distance between these is just a matter of differences in those bits. The distance is going to be once again 1. Not too exciting of an example. I guess off the cuff here, distance between these 2 code words would be, for a 4-bit code, would be 4, because none of the bits match. So let's look at these 2 codes here. Once again, they're circular. So this is the first code word. This is the last code word. The code word after the last code word is going to be the first code word again. I need to look at these going from code to code and make sure only 1 bit changes, and that's going to tell me it's a unit distance code. So 0, 1, that's good. Only this bit changed, and only this bit changed. Looking good. Only 1 bit's changing at a time. Looking good. And this, apparently, the distance between all these code words is a 1. It's just a distance of 1. So this is by actual unit distance code. So let's look at this one. So distance between here and there is a 1. 1 bit is different. Difference between these 2 is a 1. Difference between these 2 code words is a 1. Distance between these code words, oh no, this doesn't look right. 0, 0, 1, 0, and 0, 001. 2 of these bits are different. I have to change 2 bits to go from one code to the other code. So this is not a unit distance code. We'll keep looking at it just for the heck of it. So this is the distance of 1. This is the distance of 1. This is the distance of 1. This is the difference. Okay. Other than these 2 code words here, this would have been a unit distance code, but because they're different, this is not a unit distance code.